Find the products for 1 and 2. Seems like a fairly straightforward question, right Gopi?
Yes. Let's try attempting the first question. And now we have the reagent as HCl, and note that only one equivalent of it is given. So
Okay.
we're gonna get only the major one.
Alright, only the major product.
Yeah. Now one thing you need to observe here is in the first compound, let's draw the structure for it. It is C triple bond C, C double bond C.
C. Alright.
And now, since you have one equivalent, HCl, you know that HCl dissociates to give H plus
And Cl minus.
Cl minus. Now both these are nucleophiles, as we already told you,
Yeah.
and they undergo electrophilic addition reaction. And now you have one equivalent, and you gotta get one equivalent of H plus and one equivalent of Cl minus. Now you need to think which one of these is better nucleophile, either C triple bond C or C double bond C.
Okay.
Now if you observe C triple bond C, the carbon here is sp hybridized, and in C double bond C the carbon is sp2 hybridized. So
Alright.
for sp hybridization we have more S character.
Yeah, as we discussed in a question before this, right?
Yeah. So it has more electronegative. That is, if this is a nucleus, it exerts a strong electron pull towards the electrons.
Okay.
So it cannot easily lose the electrons.
Okay.
But if you take sp2 hybridization, the electron pull won't be much stronger. So compared to C triple bond C, C double bond C can donate electron more easily. So H plus attacks on C double bond C rather than C triple bond C. Now H plus can attack either on this carbon or on this carbon, the same thing. Let's call it as A and call it as B. If it attacks on A, then you will get C triple bond C, C, and C is attacking on A, so the bond is shifting in this direction, so you get a positive charge here. But if it attacks on B, you will get C triple bond C, a positive charge here and hydrogen here. Now this is more stable because it has more hyperconjugation forms, which are 3 from here and 2 from here. So this is not formed and this is formed. And Cl minus attack on this carbocation, you will get C triple bond C, CH2, CH, Cl and CH3. Seems to be very simple one. Now
Alright.
let's come back to the second part of it, where you have C triple bond C, C double bond C.
So it'll be pretty much the same, right?
That's what we think, and we write the product as C triple bond C, CCl, C. But this is wrong
Oh.
because
Resonance?
yeah,
Oh.
if you observe carefully, C triple bond C, this triple bond and this double bond are in resonance. So
Oh.
first H plus attacks on this carbon. I'll show you why.
Okay.
You have C double bond, triple bond C, C double bond C. If H plus attacks on this carbon, this bond will shift in this direction. You get a positive charge here, and so you will get C H double bond C plus C double bond. Now you can observe that this positive charge is in resonance with this double bond. That is, it is stabilized by this double bond. I'll draw out the resonating structure for you. C double bond C. This bond shifts this direction. So this positive charge is delocalized. As a result of it, delocalization reduces the energy, so it is more stable.
And
now,
this is even counterbalancing the effect of two double bonds being next to each other as well? Because that also creates repulsion, right?
huh.
Okay, but this
But
is still
this is stable.
more stable. Alright.
And yeah, that's what you told. If these are here, it will suffer repulsions.
Exactly.
So in the mixture, we have this product more.
Okay.
And hence the Cl minus attacks on this carbon and not on this carbon.
Okay.
And the product that you got is C double bond C, Cl, C double bond C. And there is a name for it. It is called as neoprene.
And is this the same compound that is used in rubber tires? And
Yeah,
all of
polymerization.
This? Oh, exactly. We studied this in our 9th class as well, from what I remember, right?
Huh.
Exactly. Oh, wow. So, chemistry has an interesting way of coming back to you.
Yes. Now, I want you to find out what would be the product if it is polymerized.
Okay. Guys, give this a shot, or you can just look back at your 9th or 10th NCERT textbooks and be able to
It's
identify
also
it.
there in your 12th standard.
Exactly. So, it's all over the place. So, let's move on to the next question now. So, after the last question on resonance between two particular bonds, let's come on to question number 6, where we have to find the product formed in the reaction below. The reaction will involve multiple reagents, the first of it being NaNH2 in excess, and then the subsequent ones. So let's try and solve it for the first one, Gopi.
Yes. First one is NaNH2. We know that NaNH2 gives Na plus NH2 minus.
Okay.
Now this NH2 minus will act as base if there is any acidic hydrogen.
Okay. Present within the system.
Yeah. If not, it acts as nucleophile. Now, in the given compound, we have two acidic hydrogens. This one and the hydrogen attached to OH.
Okay. And OH is more acidic, right?
Yeah. But we have excess of NaNH2. So, NH2 minus takes hydrogens from both these oxygen and carbon.
Okay.
And the one you are going to get is O minus C triple bond C minus.
And these are going to be stabilized by the sodium atoms.
Yeah.
Okay.
Electrostatic bond exists between them.
Okay.
Now let's come to the next part of it, where you have only one equivalent of ethyl iodide, that is CH3CH2I. Now these two are nucleophilic sites. Since you have only one equivalent of this ethyl iodide, you have to tell which of this is better nucleophile. We already discussed that C triple bond C the carbon has less electronegative than oxygen. That is, it has more tendency to donate electrons when compared to oxygen, because oxygen has more electronegative than carbon.
Okay.
So this has more tendency to donate electrons, so it will attack here and this leaving group departs away.
Okay.
And the one we are going to get is O minus C triple bond C C2H5.
Okay.
And for the next part we have one equivalent of CH3I. Here we have no more nucleophile other than oxygen, and it attacks
And
this leaving group departs.
Okay.
And the thing you are going to get is CH3 O C triple bond C C2H5.
Okay.
Now
And then we put in some Lin-Lar's agent.
yeah, Lin-Lar's catalyst. This Lin-Lar's catalyst is already known to you. It is palladium in presence of barium sulfide. We discussed already that this gives you
Only alkyne to
cis alkene.
But it won't go on to alkane.
Yeah.
Exactly.
So you got to get a cis product here. CH3 O C C double bond C cis 1 H C2H5. This is your final product.
Alright. Is there anything else we wish to tell them?
Yeah, it's actually a previous IT question.
Oh, wonderful. So, students, as you can see, these multiple chain of reactants will keep coming and you'll have to find a final product. So be careful at every step because messing up even one step can lead to a mistake in the final product. Now that we've managed to solve this, Gopi has another question for us where he's going to make you explore your thoughts and come up with an answer.
Yes. Now, if you take the same reagent that you have given and you add only one equivalent of NaNH2 and you do not have the third step that you have previously.
Okay.
And you have the second step which is C2H5I.
Okay. And then we have the fourth step which is
Lindlar's catalyst.
Okay.
Now I want you to find the answer for this one. Now I'll give you the answer if you want.
Okay, let's give them the answer. They can figure out the mechanism.
Yes.
Okay.
The answer is CH3O double bond H H H.
Okay, so this looks interesting. Seems like there was an elimination somewhere in there. But let's leave it up to them to figure out. Okay, students. So with this, we end this question and we'll move on to the next question now.
Okay, Gopi, let's start solving this question. In this question, we have to find the product and comment upon its stereochemistry.
Now, first look into the compound given to us.
Gopi, can you tell the name of this compound?
Yeah, I'll name it first. You have C double bond C, here CC and CC here. Now, as per IUPAC nomenclature, select the longest possible carbon chain and this is the only longest possible one and name it 1, 2, 3, 4, 5, 6. So it is hex 3E. Yeah. Now let's come back to this. You are given Bayer's reagent. First, what is Bayer's reagent? It is cold alkaline KMnO4. That is, KMnO4 is present in basic medium. This is cold condition. So unlike hot condition which involves bond cleavage, that is cleavage of C double bond C, it won't cleave bonds completely. Rather, it will break only one bond of it.
So in hot conditions, the sigma bond will also be broken.
Yeah. Here only pi bond will be broken. Now, the structure of KMnO4 is Mn double bond O O minus double bond O. There will also be K here. Now you got this alkene C double bond C C2H5 H H C2H5. Now syn addition occurs here. So you're going to get,
So the OH will be attached on the same side.
yeah, CC OH OH C2H5 H C2H5 H. Now in the question you are also asked to find the stereochemistry of it.
So let's draw its Fischer diagram
Yes.
to understand its stereochemistry.
Yeah. Now these two are chiral carbons if you see, because these
all of the groups are different only.
yeah. Let's consider these are our carbons, and if you see here, two OH groups are on the same side. That is OH OH, and two ethyl groups are also on the same side. That is towards this side and towards this side.
Compound is symmetric.
Yeah. C2H5, C2H5, and finally keep the hydrogens. Now, if you see here, this compound has a plane of symmetry. So, what we got here is,
It's meso.
yeah, it's a meso product and it's optically inactive. Now, at this point, we want to give you a shortcut. That is, this shortcut is regarding addition reactions of alkene, basically to unsymmetrical alkene. It's an alkene which is bonded to different groups. Yeah. Always remember that you get either of the two products. One is racemic or meso. Now, if you are given cis alkene, if it undergoes anti-addition, then you will get a racemic product. You can remember this by CAR. C-A-R. Now, if it got
What about sin?
sin addition, you will get meso for it. Now, if you take trans, if it undergoes anti-addition, you will get a meso product. Just reverse to it, and you can remember this by
It will form TAM.
TAM. T here, A here, and M here. Now, if it undergoes addition by sin, you will get racemic mixture. Yeah. Also keep in mind that this is only for unsymmetrical alkene. So, let's move on to the next question.
Okay Gopi, let's try solving this question in which this terminal alkyne is treated with this series of reagents and you have to find the product.
First, the compound given to us is, you have carbon and C triple bond C, and to this carbon you have 3 methyl groups attached. First, let's try to name this compound. As per IUPAC nomenclature, you have to select the longest possible carbon chain, and this 4-member chain is the longest possible carbon chain.
So it will be a bute.
Yes. And next thing is you have to number this 1, 2, 3, 4. This is because this gets less number as possible, and the name would be 3,3 dimethyl bute 1,9. Now let's get back to the question. In the first part, you are given dilute H2SO4 and HgSO4. You know that H2SO4 is an acid, so H2SO4 get dissociated to H plus and HSO4 minus.
And this and this H plus ion will attack the electron cloud of the alkyne.
Yes, because you know that alkyne is a nucleophile, and this H plus can be attacked from this carbon or from this carbon. Let's call it as A and this one as B. You are all pretty sure as to onto which carbon this H plus attacks. Now let me tell you this again. If this gets attacked by carbon A, say call it as A, you get H here, double bond C, this bond shifts in this direction, and you get this direction, and you get a positive charge here. And say that it attacks on side B, you will get positive charge here.
We will get a more stable carbocation here.
Yes, this is because
it is stabilized by these R groups.
Yeah, they have inductive effect, and this is at a larger distance and this is at a smaller distance, so it is more stable. Now, next part is addition of water. You have water in the solution, they get adds to it, and you will get 3 methyl groups, C OH, double bond CH2. This is basically called as an enol. because you have ene here and OH group all here. Enol.
But Gopi, will such a simple question come at IIT exam?
You are correct, because this is present in acidic medium, and in acidic medium enol gets converted to keto form, and we call this process as tautomerization.
Keto-enol tautomerism.
Yeah, keto-enol tautomerization. You are all taught this in your GOC, but now let's look into the mechanism of it. First, this H plus attacks on this carbon atom. I'll tell you the reason for it. As you can see, if it attacks on this carbon, this bond shifts this direction and you will get a positive charge here. That is, you will get CH2H here and positive charge here. And now oxygen here has lone pair of electrons, and it donates its lone pair to carbocation, and the carbon fulfills its octet. You will get double bond OH plus and CH3. You also have water, HH. Now this takes it, and you will get.
So it will be taken by the medium, the H plus
Yeah.
ion.
And you will get the product as a ketone.
So our enol has converted into a carbonyl compound.
Yeah.
Will this occur in basic medium also?
Yeah, tautomerism also occurs in basic medium, as you have seen in your 2-3 examples before. Now let's look into the second part of it, where you have treated this with
NaBH4.
NaBH4 in the presence of
Ethanol.
ethanol.
So NaBH4 is a good hydride donor, no?
Yeah, hydride is H minus. H minus is a very good base if there is acidic hydrogen. If there is no acidic hydrogen, it acts as nucleophile. So here there is acidic hydrogen, this one, but it's not very much acidic for H minus to get abstracted by this. So, but it's a very good electrophilic site.
So it will act as a nucleophile.
Yeah, it will act as a nucleophile, and you will get CO minus, H here, and CH3. Now,
So a nucleophilic addition is taking place.
yes, you'll get to know this in your carbonyl compounds, don't worry. Now, the third part of it is you're adding H3O plus. That is, you're supplying acidic medium, and this O minus takes this H plus, which is obtained from this acidic medium, and you will get an alcohol, which is a tertiary alcohol basically. Now,
So the alcoholic hydrogen is coming from the reagent.
yes,
So if we have D2O there, what will happen?
I'll tell you that. If you have D3O plus here, then instead of H, you will get D here. But if you have D2O in the first reagent, that is in the presence of H2SO4, if you have D2SO4 and HgSO4, and in the presence of D2O, it will tautomerize differently, because as you can see in the tautomerization here, there is no H plus and there is D plus. Now I have shown you the mechanism here. I want you to try out this one. What happens when D3O is present in the first medium reagent? And we also wish to give you one more thing, that is extension of this question. Let's call the final product as X, as given in the question. What if this X is treated with the following reagents? One is dilute H2SO4, the second one is O3 in the presence of CCl4, which is non-polar solvent, the third one is zinc. I'll give you the answer for it if you want. You will get acetone here. The answer is acetone. As a hint, I'll tell you this one. You have H2SO4 here and a secondary alcohol here. Look if there is a possibility for dehydration. And you have O3 here. See if you will get an ozonide. And you have zinc here, which indicates reducto-ozonolysis.
So let us summarize what we did in this question. First, H+ attacked the dense electron cloud of the alkyne to form a carbocation, and water attacked on that carbocation to form an enol, which tautomerized to form a carbonyl compound.
This one.
And then hydride attacked on that carbon compound.
This one.
Which came from NaBH4.
Yes.
To form an alcohol.
So here we end up this question. Now let's move on to the next question.